Hello everyone, welcome to this video. In this video, we'll be talking about another result which tell us that conjugacy classes partition the group. Now, until now, I think you might have guessed that we are talking about partitions. Why? Because if you remember in the previous video, I have told you this observation that all the conjugacy classes, they are either disjoint to each other, right? Each one having contain the elements which are not there in the other conjugacy classes, and moreover, if they have the same equivalence, if they have some elements common, then they are equivalent to each other. For example, the conjugacy class for R90 is equivalent to the conjugacy class of R270. The conjugacy class for H is equivalent to the conjugacy class of V, and the conjugacy class of the element D is equal to the conjugacy class for the element D dash, right? So having made this observation, if you remember, using the Lagrange's theorem, we also showed that the cosets of any subgroup partition the group, right? Because I have mentioned in the previous video that the cosets of some subgroup H of the given group G, which is finite, that partition this group G into equivalent classes, right? And the equivalence relation is defined by the following, where we have some element A related to element B, where both A and B are members of G, right? When can we say both of them they are related under this operation and under this equivalence relation, which is defined by cosets? Whenever the coset which is defined by the first element A is equivalent to the coset which is defined by the second element B. So we have AH is equal to BH in this case, right? So using we have partitioned our given group in terms of cosets. Now we can also partition our given group in terms of conjugacy classes. So you can see that the group D4 clearly partitions into 5 partitions, right? One is this R0, it contains only one element. Then we have R90 and 270. So another partition containing 2 elements, right? Then we have the third partition containing only one element. The fourth partition contains 2 elements H and V, right, this one, and the fifth partition contains 2 elements D and D dash, right, this is this one. So this forms the partition of the group D4 under the conjugacy class, right? So we see that conjugacy classes, they also provide us another method to partition our group, right? In fact, we have a result which states that conjugacy class form an equivalence relation. This symbol here represents the equivalence relation, and we define that equivalence relation by stating that if we take 2 elements A and B from our group G, then both of them, they are related to each other whenever they are conjugate to each other. So mathematically that means that whenever we are able to write this B as x A x inverse for some x in G, then we would say A is related to B, right? And moreover, whatever is the conjugacy class of this element A, that forms the equivalence class of this element A under the operation of conjugacy. So that means we are able to partition any group into disjoint conjugacy classes. So in the next video, we'll be looking at the proof of this result. Well, that is it for this video. Thank you for watching.